Our next speaker is Zvi Figov from Microsoft. Zvi is a data scientist with over 20 years of experience in various computer vision fields. He currently works in the Azure Video Index group at Microsoft. He holds a BSc and MSc in computer science and mathematics from Bar Ilan University. Zvi has a vast experience in computer vision application, including deep learning, object detection, and tracking.
Thank you. As I said, I'm Zvi Figov. This work is was done together with Moti and Yonit. And the topic is Person Tracker for Media and Entertainment Videos. I'm from the Video Indexer group at Microsoft. And we'll start. So what is Video Indexer? So Video Indexer is a product of Azure, Microsoft Azure, where you can upload a recorded video and extract insights. It's a product that's used by largely in the media companies, like news companies as well. And it extracts insights, like as we see at the top, could be faces, could be people as well. And here what we call observed people are basically people tracking, and we extract the thumbnail of each person that appears inside the video together with their appearance when they appear in the video. This is a basic insight which we use in Video Indexer both by itself and also in combination with other insights. I don't know if you can see, but underneath here it's got for that particular person what they're wearing, etc. So what we're going to speak about today is how we've taken a person tracker, which is usually people think about surveillance cameras, and we've taken that to the world which we deal with, which is media. And so before I go into that to explain about what we've done here, we'll first speak about the general flow of person tracking. So usually we're talking about tracking by detection. We have our detection. We have re-ID embedding, which could be any kind of appearance based on appearance model. And both these are inference models. We then, if we're ready in this example, we already have two tracks, track ID 22 and 25. One is the blue person, one is wearing blue, and one is wearing white. So we're taking information of the current frame, and we're comparing them to the previous tracks. This is based on the embedding, which is the appearance model, but also based on the other information. Could be based on motion, could be based on where they are, the spatial information. Using our association matrix, we discover who is nearest to who, and based on that, we decide that the person appeared in our current frame in blue belongs to the track ID 22, and the white belongs to the ID 25. And we have the final stage, which we call track management, which is basically to decide do we need to open a new track, or are we just updating current tracks? So what are the challenges that are specific to Video Indexer? Or an indexer tracker. So if we speak about the differences, in media, quite often we have editing effects, which can, in this example, we have a short clip of 6 seconds, and we have 3 different shots that appear. I'll just try and pronounce that. That was just to make sure I get an applause. So there are editing effects, and why are editing effects difficult for tracking? Usually when we do tracking, we have a spatial coherence. In other words, we have a scene, we're tracking all the information is spatially coherent in the scene. And here in this example, we've seen in a very short time, we can't use that spatial coherence. In general, there are quite a few numbers of differences between surveillance and media entertainment. One, which I like to say, is that if you think of a sitcom, every time someone speaks, that person is in the center of the frame. You switch to the other person, they're in the center of the frame and back again. Whereas in surveillance cameras, usually the person does not want to be seen. That's just one example, but there are other differences as well, like frame rate, the noise, compression, and I won't go into all that, but it's very important. What we did here is to understand the domain, and this we'll get back to as well. By understanding the domain and what we can do, we can then tailor to create a tracker which is specific for us. Other than that, we have some constraints. We're working only with CPU and not with GPU due to cost, availability in the cloud, and also runtime. We would like it won't take too long as well. So we have some limitations. And what we will see, we'll speak about shot detection and other changes we've done to bring our tracker that will be specific for video indexer or specific for media and entertainment. So first of what is global shot detection? So global shot detection is a known topic. Usually you speak about abrupt changes and about gradual changes. And we can see here an example where two different camera views or camera are put together. And we have an example for 2 frames of the different cameras. And what we wanted to do here is to say that the large shot detection is something which the abrupt shot detection is something that we can easily detect using histogram, using simple sort of methods. And we're not going to try and solve the whole problem of the gradual change detection, even though we also have that in our system as well, because we want something that can be efficient. So if we don't use shot detection, our tracking, so here is the frame just before and just after the shot detection. We can see that ID 41 is correct. The same person appears in both the frames, whereas ID 10 is an ID switch, means that we gave the same ID to 2 different people. If we use the knowledge of that there was a shot detection, then we can say we don't want to use the information of the spatial content, only use the appearance information to do the matching. So if we look at the whole pipeline of how we use the shot detection, we use it in a few ways. First of all, we have our video buffer thread that takes a video file. As you remember, we're working in batch on recorded video. We have a shot detection, and we have a frames queue with a shot indication. We have another thread which takes frames when they're available together with a shot indication. And we have a detection aware based on the shot detection that if a shot has changed or every n frames, only then we apply our detection. Otherwise, we just interpolate the frames. This allows us to have high quality, even though just when the shot detection occurs, so we have a detection just before the shot and after the shot, so we don't lose the information. The other area where we use the shot detection is for the association. In other words, if there was a shot change, then we use just the appearance information, whereas if the shot hasn't been changed, then we use the spatial information together with the appearance information. We've done other optimizations also specific for media. Previously, we were using a full body detector, and we moved to using the human pose, because people are sitting down in media, etc. And so we've done that. By moving to key points, we use filtering based on the key points. We representative choice, which we showed at the beginning, also based on key points. And we have an efficient pipeline running in parallel for reading the video and processing the video. So we have a data set. We chose 20 diverse clips. As we can see, the sitcom on the top is really edited. We have some social media. We have a typical surveillance camera as well. And our result, when we calculate our statistical results, we're looking at 3 areas: at the detection quality, the track quality, and the processing time. We have our baseline relative to our improved. Baseline is without all these other modifications. And we can see that precision has improved in our improved version, but the record has gone down. And the F1 score is more or less the same. And it's important because we're very customer focused, and it's very important for the customer perspective to have a high quality detections for the precision. But what's more significant is the tracks quality. The ID switches have significantly gone down. The fragmentation's gone down also by 10%. And the turnover duration has gone down also by 50%, which is significant. So just summing up, we presented a novel pipeline for person tracking of videos that was tailored for media and entertainment videos by, as I said, understanding the domain and applying it here. We obtained improved results, reduced the computation and the cost, and it's running in production at Video Indexer. Just connected to the previous presentation that if you take in your clips and index them, you could see all your kids, and this is something you could do as well. Thank you.